Hello again. In this video we will be solving problem number 8. So this problem asks us to use series to approximate the definite integral of I to within the indicated accuracy. So the problem we get is I equals to the integral from 0 to 1 of 4x times cosine of x cubed. The first thing we need to do is to find the property of Taylor series that adequates better to cosine. This one, it's located on the top of the video, and it's cosine x equals to the sum from n to n equals 0 to infinity times minus 1 to the n times x to the 2n over 2n factorial. Once we have this, we can input cosine x cubed. That will give us as a result the sum from n equals to 0 to infinity times minus 1 to the n times x cubed to the 2n over 2n factorial. That will give us as a result the sum from n equals to 0 to infinity of minus 1n times x to the 6th n over 2n factorial. Now we can impute the 4x. That will give us basically the same result, but we need to multiply. We leave the 4 outside of the summatory and multiply the x times the x to the 6th n. So we will get as a result 4 times the sum from n equals to 0 to infinity. It's equal to minus 1n times x to the 6th n plus 1 over 2n factorial. Well, once we get here, we apply the integral, leaving the problem 4 times the integral from 0 to 1 of x times cosine x cubed of dx. That's equal to 4 times the integral from 0 to 1 of the sum from n equals 0 to infinity of minus 1n times x to the 6n plus 1 over 2n factorial dx. After that, we can forget the 4 for now, but remember, we'll use it later. Next step now, it's applying the integral. That will leave us as a result the sum from n equal to 0 to infinity of minus 1 to the n times x to the 6th n plus 2 over 6n plus 2 times 2n to evaluate on 0 and 1. After that, we can evaluate them, and we will get as an answer, when we evaluate with 1, the sum from n from 0 to infinity minus 1 to the n over 1 to the 6th n plus 2 over 6n plus 2 times 2n minus the sum of 0. That's what leaves us when we substitute by 0. Now that we have the result, we can start applying the Riemann sums on the sum from n equals to 0 to infinity of minus 1n times 1 to the 6n plus 2 over 6n plus 2 to n factorial. Substituting by 0, that will leave us minus 1 to the 0 times 1 to the 6 times 0 plus 2 over 6 times 0 plus 2 times 2 times 0 factorial. That will leave us 1/2. Then we can substitute by 1, by 2, and by 3. This will give us the answers of, when we substitute with 1, we will get 1 over 16, by 2, 1 over 336, and 3, 1 over 14,400. Now that we have these results, we can sum the first 3 values we got. That will be 1/2 minus 1/6 minus 1/16 plus 1 over 336. That will give us almost 0.440. Also, if we divide 1 over 14,400 will give us 0.0007, proving that we're on the correct way. After that, we can do the first sum on like the first input we did and multiply it by 4, giving us the answer 2 minus 1/4 plus 1 over 83. That will give us 1.7620.